Hey everyone, we're here for our next talk, which is on fighting the MEV crisis with batch auctions, one cow at a time, with the Gnosis team. And I'll let them take it from here, and CowSwap.
Thank you. I want to welcome everyone. Good evening, good morning, or good night, depending on where you're watching. And today I'm going to talk to you about CowSwap, or what's most important is the underlying mechanism, the trading mechanism that is powering CowSwap today, which is Gnosis protocol. And that mechanism, the trading mechanism, is based on batch auction, and we think that it's a key mechanism to prevent the MEV, the minor extractable value, or also known as maximal extractable value. And that is why the name of this talk, fighting the MEV crisis with batch auctions, one cow at a time. So the outline of this talk is divided into pain points of DeFi trading today, or DEX trading today. Where are GP Gnosis protocol core ideas? How do we apply the mechanism in practice? And lastly, how we think collaboration can benefit everyone as a whole. So what are the current pain points of DeFi trading today? The biggest pain point for DeFi trading today that we have found is transaction management. Why is that? Because choosing a correct gas price for your trades to execute is quite hard. Actually, if you've done a trade within the past 6 months or within the past year, you've noticed that the gas prices have been extremely high, and also extremely hard for, as a retail user, to guess what are the most optimal ones. Even with the introduction of EIP 1559, it's still quite hard as a retail user to choose what is the correct gas price for your trades. In a study we did back in January, we found that people on average using the same AMM and similar size transactions were overpaying 11% more than necessary to execute their transactions, meaning that for executing a trade, the users had to pay more than 11% than what it should have cost. Of course, as a user, you can also say, okay, well, I just want to execute my transaction and I don't mind about when it gets executed, so I'm going to choose a low gas price, and therefore my transaction is going to sit in the mempool. Well, in order to be able to do this, you need to allow the trade to have certain lags, slippage for it to happen. But there is a problem. In a different study that we conducted, we observed that on the DEX aggregators, that usually the best route, so the most optimal path for your trade to be settled, so in other essence, the liquidity pool that offers you the best on-chain price usually changes from 15 seconds to 1 minute. Of course, as a normal user, like this doesn't impact you as much, but it's still impactful because let's say that you can get a better on-chain price. You're currently wasting it by signing the executable transaction and sending it to the Binance. But this is also very painful for other people, such as the people who run DeFi protocols or DeFi teams or DeFi funds, and they usually have a setup of multi-sigs. This is a problem because when you're trying to execute a transaction with a multi-sig account, it usually takes more than 1 minute to actually authorize the transaction from when it gets executed. And therefore, knowing that the best path for your trade is going to change from 50 seconds to 1 minute makes it quite painful, because you know that you're not going to get the best available on-chain price. Then also, it sucks that as a user, sometimes you can have it that you have to pay for a transaction even though the trade hasn't actually gotten executed, because some things might have happened or just the transaction might have failed. In a study, we found that 18% of Uniswap transactions and 10 to 50% of the DEX aggregator trades were failing, meaning that the end results were that the users had to pay for these transactions and yet nothing happened. So it sucks to have a high likelihood of failure transactions. The second biggest point of DeFi trading or DEX trading today is what is known as minor extractable value. But why does minor extractable value exist? Well, the reason that MEV exists is because the execution price purely depends on in which index within your block your transaction is mined. This means that the price of your token trading pairs that you're going to trade depends on what index of within a block your transaction has landed. In here, what we can see is a random Ethereum block that we pick, where we see the same token pairs, UEFI against ETH, and we even see that within those 5 trades, all five of them got different prices, even though 4 of those trades were also in the same AMM protocol. Of course, you know, as a user, you always want to get the best price. So you're gonna say like, okay, miner, put me in the spot that gives me the best price. But then you realize that as a user, you have no control. The miner is the entity, the person that has the ultimate control over the ordering on those transactions. And you can rest assured that the miner is going to place those transactions in a way that benefits them the most and not in a way that benefits you as a user. Because you have to think that not only you can also give them the gas fee for executing the transaction, but you're also giving the miner the chances to extract value by sending them your executable transaction already ready to go. So to quickly recap, what are the main examples of MEV? So the first one and quite painful one is the front running, because in front running, what can happen is that you submit a transaction that you've sent to the mempool, and then the miners notice that transaction. And because that transaction has created some sort of value, then what the miner can do is replicate the transaction and put the miner's transaction itself before your transaction, so that the miner's transaction is the one that gets the value and your transaction is the one that fails. This can be quite successful for the miners, because, for example, in the event of a smart contract exploit where you have detected and you're acting as a white hat to save the funds, the miners can see that and basically like exploit the protocol before you go to save it. Or, for example, if you have noticed like a chance for a heavy liquidation and you got an asset with discount, then the miners can also be the ones that front run you and get that discounted asset instead of you. Then the second example of MEV is back running. This is not as helpful for the user, because your transaction still gets executed, but it's helpful in the way that as a user, you're still getting value extracted from you. So value that should be given back to your hands. Because, for example, if you're a large DeFi fund or like a large DeFi trader, and you know that you're going to trade like 10 million of Ether against USD, you know that you're going to move the reserve price of an AMM and then therefore create the non-pair stability of the other AMMs in the liquidity pools. So you know that you have to submit multiple transactions to bring all the liquidity pool of those tokens pair prices even. But then what the miner is going to do, that because they have seen that your transactions creates this arbitrage opportunity, then they're going to just place the transaction right after yours that gets all the arbitrage opportunities for them. And lastly, one of the most painful attacks on a user of MEV is a sandwich attack. And essentially, this is the most painful because as a user, you're ultimately giving the worst price for your trades. When you're interacting with any AMMs, you might think that you're doing a market order, that you're placing that, but instead what you're actually placing is a limit order, because what you have accepted and signed the transaction, the executable transaction, is that, okay, I accept this price, but then I am willing to, because of the slippage, accept a price movement of, let's say, 3 to 4% that can either go up or can either go down. So in that case, what the miner can do is that by observing the trading amount that you're going to do, the miner will actually, if they're interested in buying in the same asset that you're also doing, will place a buying transaction so that the transaction just before yours moves the price to the maximum limit that you've set with your slippage, meaning that you get the worst price. And then after your transaction is placed, then also your transaction makes the value of those tokens pair go up. And then ultimately, right after that, the miner immediately sells. So that's the opposite trade of the beginning of the trade. So the miner has extracted all the value from you because it has given you the worst price by buying low. You have bought at the price that the miner has wanted, and then right after you, the miner has sold the asset and therefore making a profit because they bought low and sold high. But what are some of the numbers behind MEV? So here we can see like a current graph of the total MEV extracted since January 1, 2020, it's from last year. And we can say that it has been like an exponential and enormous growth alongside with the growth of DeFi itself, because the more value that is transacted in DeFi, the more the miners is going to extract from the users, because the bigger the pot that there is to share. This tool has been put together by the Flashbot teams, which is a great team at who's trying to democratize and make visually public everything available then when it comes to MEV. But not also in numbers, we've also seen it in Twitter. There has been many celebrities in which they have asked, how can we stop MEV, or how can they buy, invest in MEV if they can find a token or anything. Or even it has gone to the point that media outlets like Condex have called this service, like front running or MEV service, a theft, and they actually want to ban it. Of course, we're not in the business on banning people of what they can or can't do, because Ethereum is a decentralized infrastructure, but we do think that there are several ways in which if the users collaborate and trade together smartly, they can avoid getting MEV by the miners. And thirdly, the last problem of DEX trading today is that there's liquidity fragmentation. Liquidity is completely fragmented across many DEXs, and many of them are no longer native to Ethereum, or even if within Ethereum, they're also in different like layer 2s or different size chains. So as a retail user, it's very, very hard to stay up to date in which DEX portal gives you the best prices on certain type of assets. So of course, because of the convenience as a user, you're most likely to go to your normal, regular, average AMM because you're not able to stay up to date with everything and just trade there, meaning that you're going to get a worse price. Another way that we can see the liquidity fragmentation is, for example, if we think of how many different dollar representations there are in crypto. We have over 4 or 3 different major crypto dollars that are scattered around the ecosystem. And depending on where you're trading, it might be more economical for you to trade against this type of dollar than to trade against the other type of dollar. But how does Gnosis Protocol and CowSwap tackle all these problems? Well, if you recall, the first problem we talked was transaction management. How can we fix transaction management from the retail point of view? So what we want to do is that we need people to stop signing executable transaction of how and when they want to execute a trade and then giving them directly to the miners. So today what we have is that the users logs in with their wallet to an AMM and then they sign the executable transaction and hand it to the miner. Instead, what we are proposing and what the users think they need to do is that instead of signing this executable transaction, they need to sign this message and hand it to the solvers. But where are the solvers? The solvers are this third party, professional party, who is in charge of executing the transactions for you. So sending it to the miners for you. These solvers can do great things because they allow them, by receiving these intents to trade, it allows the solvers to bundle multiple trades together in the same atomic batch. And also it allows them to hedge the risk for the users. So as a user, you no longer have to worry of what are the gas prices or where is the best on-chain price for you to execute the trade, and if you're actually going to get front run, but rather just send to the solver an intent to trade. I want to trade token A to token B, and then the solver is the one who, for a fee, is in charge of settling those transactions for you. But you might think, this is a bit similar to what we do to the miners. And yes, it is similar, but with one big difference is that the solvers do have a bonded relationship with the protocol, and they're interested in actually executing the transactions in the way that benefits the users the most, because if not, they're not going to be the ones to settle the solutions in these protocols. So whereas the miners are completely free riders within the Ethereum ecosystem, they don't have to bound respects to anyone. In this case, the solvers of Gnosis protocols do have to bound respect to the users, because if not, they can be slashed and their bond can be taken away. So one of the with delegated trade executions, there comes certain advantages and there comes certain drawbacks. So one of the main advantages is that the trader doesn't commit to a concrete execution path. So as we saw before, one of the problems was that the crypto volatility makes the best on-chain path quite changeable for a very short time. So as a user, you no longer have to think of where you're executing your transaction, but rather rest assured that the solvers are going to choose the best route or the best optimal path for your trades. Also, another addition that comes with this concrete, non-concrete execution plan is that since you're signing a message instead of signing a transaction, your trade is only going to be charged the fees if the solvers manage to execute the transaction. So meaning that order placement is free. As long as the solvers don't execute your transaction because it might have expired or because of many other reasons, then you're not charged a fee. So you're only going to be charged a fee if the transaction has been successful, and therefore creating a gasless experience. And this gasless experience, if you're an ETH lover, allows one of the greatest things that we believe and that we're enabling, which is that you no longer need to pay your fees in Ether. You can just trade or place orders and pay the fees with your sell tokens. Although there is a slight drawback. Because we're doing this trade delegation, there is a signature verification that needs to happen at the smart contract level. This signature verification gives a slight gas overhead because we have to double check the two contracts. One, the allow list, the author contract, where you have allowed the contract to spend your funds, and then for the settlement contract to check that you have actually been the author of that trade. Of course, this is a bit of a drawback if you're in a single batch trading alone. But if you're bundled together with more people, then there are more, which is usually the case, there are more advantages and cost savings that this slight gas overhead. So how do we fight MEV? How do we protect the users from MEV? Essentially, what we want to avoid, as we said, is this concept of price time priority ordering within a block. We wanted to make it non-meaningful. So in essence, what we believe is that, for example, on the left, we can see how we've had six different trades on the same token pair, and yet some of them have same price, but some of them have different prices, and all of them have a different cost of execution. So the fundamental thing that we want to avoid is this. If two people are trading on the same token pair in the same batch or in the same block, they should not be getting different prices. They should instead be getting a uniform clearing price, because essentially there is no information advantage within the same block of you being on one index before, like 39, or being on the index 51, but rather that all information in the same block should be valued the same. So that's why all our trades are settled in the batch options with a uniform clearing price, meaning that the solver is the one that decides what is the most optimal gas cost for executing that transaction, and then is forced to give on the same token pairs that are traded in that batch the same clearing price for everyone. And therefore, if we remove the importance of the order, we're able to get rid of MEV from just ordering the transaction. But essentially, where does this protection comes from? The protection comes from because since we're leveraging batch options as a trading mechanism, it's allowing us to do this cool thing that we can basically split the batch option into two parts. One part which is called the coincidence of ones, and the other part which is the excess of the coincidence of ones. The coincidence of one part is the trades that can be settled peer-to-peer and off-chains, and therefore combined with the AMM settlement, they give together a whole complete batch. And the part of the coincidence of ones, since it's fully off-chains, and the trades are non-dependent on liquidity pools, then there is no MEV to extract from there. But if in the case that there is no coincidence of ones, then the excess of the batch, so the remaining liquidity that's in that batch, needs to be settled on the best on-chain prices. But recall how, since we've delegated the transaction to a professional party, that professional party is the one that is interested in staying always up to date in what are the ways to minimize MEV for their users so that they can earn the fees. This way, the solver, what it does is it protects those on-chain trades by setting a tight slippage and basically resubmitting the settlement solutions until the transaction gets fully mined. Lastly, how do we solve the problem of liquidity? How do we get the most out of liquidity? So if you recall, we've been talking about coincidence of wants, and that's actually where the name CowSwap comes from. And mainly coincidence of wants is this economic phenomena where we have two parties that each hold an item that the other wants, usually is the opposite, so they exchange indirectly. So in the real world, we will have the example of if we're at the airport and we're in the currency exchange converter. So instead of having to rely on this currency exchange converter, we're in the line and we start asking the people in the line, what are they trying to sell or what are they trying to exchange? If we find a person that is opposite to us, that let's say they have dollars and want euros, and I want dollars but have euros, what we do is directly exchange the assets amongst each other, and this way we get a better price because we don't have to pay the commission of the currency exchange converter. But how does this apply in the crypto world? So in the crypto world currently, like if you're trading against an AMM, you're trading against a liquidity pool. So a person is performing a trade, it deposits an asset into the liquidity pool and subtracts the asset that they want from the liquidity pool. Of course, for this service, the liquidity providers charge a fee. So in this case, if we have two people going there to the liquidity pool to trade in the opposite directions, they both charge a 0.3% spread. The way it works on Gnosis protocols is because we have this perfect coincidence of wants where the user that we have selling is dollars for it is exactly matched with the users that is trying to sell Ether for dollars. Then there is no need to settle this against the liquidity pool because we can match them directly amongst each other. But this way, of course, the Gnosis protocol is not the intermediary, and the trade is settled directly amongst them. But one might say, okay, like it's usually impossible to find perfect coincidence of wants all the time. Well, it is, but if you think about it, in most of the trades, there are certain non-direct coincidences that we do share. So for example, we have this here. If you want to sell a token for US dollars, you usually hop like token to WETH and WETH to dollars. And if you want to buy, you do the same. You do from dollars to WETH and from WETH to the token. Then in there, we do have a coincidence of one in the WETH hub. So essentially on Gnosis protocol, we're able to bundle these trades together. And instead of having to settle against the liquidity provider $250 worth of value, we only need to settle 50 and therefore optimize the settlement much more because we have cost savings and liquidity providing fees. So the savings in the fees. So what is CowSwap in practice? So CowSwap started as this initial proof of concept and started in alpha, but is now a fully fledged product available at CowSwap.exchange. Actually, this Sunday, we just passed the $1 billion in trading volume. So thank you for trusting us if you're there and have traded with us. The user experience is inspired by the status quo of crypto, which is Uniswap, but with the slight difference that instead of sending the transaction to the miner, what you're doing is signing an off-chain message that gets relayed to the solvers. In the future, we want to have as many interfaces as possible that use Gnosis protocol as their settlement engine because we believe that the more trades that there are happening on the protocol, the more that users can benefit. But what essentially is the trade flow in CowSwap? So as we said, we have a user that connects their wallet to some of the interfaces that are available or very soon to be available, which is Balancer, CowSwap, or the Gnosis Safe. Then they sign this intent to trade that is handed to the solvers, and then the solvers conduct the batch auctions. Within the batch auctions, the solvers can have two ways, which one is the CowSwap settlement, where the solvers are trying to look for coincidence of one or bundle different transactions. And then they also get the settlement transactions ready. And then the second part, in the case that there's not enough liquidity to do trades via coincidence of one, then they instruct the trades to be settled against like all on-chain liquidity that they're connected to. So how does a batch action work in practice? So for example, in here, we can see that we had 24 different traders that placed 24 different trades. We had 10 users trading for DAI against WETH, 6 users trading WETH GNO, 6 users trading USDT against WETH, and then 1 user trading against WETH and another user trading in LYXE. So essentially, this settlement was divided into 2 parts. So first, we tried to search for the coincidence of 1, in which we found that for the token pair USDT of WETH, we were able to match 82% of the total liquidity. For the WETH of GNO, 37% was being able to find a match directly off-chain of the liquidity. And for WETH and DAI, only 2% was able to match directly. So then the rest of the excess liquidity or the rest of the trades that were being able to match peer-to-peer, then they were instructed to be settled in the best on-chain price. So in here we can see that in the AMM settlement for certain swaps, the best on-chain price was given by Uniswap, whereas for the excess of the other of the bundles of the rest of the liquidity matched via Cow, SushiSwap was the venue that offered the best price. So what do we want? We want traders and especially like DeFi protocols to trade collaboratively, because we think that if we work together, we are going to make sure to benefit from each other, and rather than playing with games against each other and out-competing us, it's more beneficial for us if we collaborate. Here's an example of how collaboration makes it better. So in here, you can see that in one of our trading challenges that we were distributing coins, we saw that actually the average amount of trades go up, but the average cost of the trade execution go down. Why is that? Because if we can get enough order flow and execute all the batch execution together, we can only give users the better price via cows, but also cheaper execution, because we also aggregated interactions and settlement together in a much more cheaper technical way. So essentially, the goal of collaboration is that to increase the space between these 2 lines, because users are going to be benefited the most. How do we get this? Well, for example, now in Balancer, if you use the Balancer interface, you can go under the settings and choose Gnosis protocol as your routing protocol, and therefore, when you're trading through there, you're going to send the trades to Gnosis protocol, and soon Balancer is going to enable that as their default interface. Also, for example, if you're just a protocol, a DeFi protocol like Yearn in this case, you can already send transactions, send trades to the Gnosis protocol, even from smart contracts. And lastly, we need your input. So a token proposal to spin out of Gnosis will just submit it to the Gnosis DAO. In this case, the Gnosis DAO members will decide on the viability of if this is approved or not. So if you're interested and would like to provide feedback, please join the forum and comment on the post. And thank you. Also, so if you have questions, happy to answer.
Cool. Alex, would you mind sharing the slides either on Twitter or on in the chat here?
Yes.
Awesome, thanks. So you mentioned before your presentation that like you guys can work with AMMs. With working with AMMs, like how hard is it for you guys to integrate with one?
Well, the thing is that it's not Gnosis protocol itself that integrates with the AMMs. In this case, because we have a partnership with Balancer, we do have had a tight integration with their new Balancer V2. Mm-hmm. But in general, the ones that integrate the AMMs are the solvers, and the solvers are the ones that just send the transactions to the AMM. So they're the professional entities that create these settlement solutions, and they're the ones in charge of sending those transactions there for the users.
Okay, yeah, that seems really cool. All right. I think they need access to your slides.
Yeah.
Cool. So I think we can wait another minute or two for questions. But if there aren't any, what's the best way for people to reach you guys and ask you more?
So the best way is to join our Discord via here, chat.CowSwap.exchange, and there we are more happy to answer any questions. You can also reach us via Twitter at MEV Protection. Usually here it's harder because we get many more requests. And also if you want to reach out to me on Twitter, you can just write me at binjasalex. I'm more than happy to have a conversation.
Okay, sounds good. I guess we can end early if that sounds good, unless you have any final words or things you want to talk about.
All good from my side. Hopefully, we have convinced some people to try CowSwap.exchange and we have new believers and users.
Yeah, definitely. Do you want to drop a link into the chat?
Yeah, I will. I need to change the slides because it doesn't allow me to change for everyone, but I will.
Sounds good.
After this, I will.
Okay, perfect. Well, I'll let you get going, and thanks again.
No problem. Thank you. And thank
Yep.
you, everyone, for listening.